All right, hi guys, this is Mrs. Rooker. I'm gonna have you guys do number one on your own, the review problem number one. So pause the video right now and do that one, and then I will go over it with you. All right, so once you've had a second to do that, now we'll get started. So the first thing you're going to do is distribute to get rid of the parentheses. So 2i times 6 is going to be 12i. And then 2i times negative 4i is going to be negative 8i squared, because we have I times I. We're going to simplify this top part before I rewrite everything. I squared always means negative 1. So I'm going to replace this I squared with a negative 1. So I have negative 8 times negative 1 is positive 8. So I have positive 8, and then I have plus 12i over 3 plus 3i. Still not fully simplified because I am not allowed to have an I on the bottom. This isn't allowed. So I need to rationalize the denominator. To do that, I need to multiply by the complex conjugate. What that means is I need to multiply by 3 minus 3i. Whatever I do on bottom, I do on top. When I do this, I'm going to FOIL. Should probably try to do that really quickly. 8 times 3 is 24. 8 times negative 3i is negative 24i. 12i times 3 is 36i. And then 12 times negative 3 and I times I is going to be negative 36i squared. Right. Again, remember I squared equals negative 1. So this whole thing just becomes a positive 36. Combine like terms on the top there. 36 plus 24 is going to be 60. And then negative 24 plus 36 is going to be positive 12. So that's what the numerator is going to be. Now I multiply to get the denominator. 3 times 3 is 9. 3 times negative 3i is negative 9i. 3i times 3 is positive 9i. And then 3i times negative 3i is negative 9i squared. The middle terms cancel. This term, that becomes negative 1. Negative 1 times negative 9 is positive 9. We add another positive 9, which gives us 18. Which, if you look, is not one of our answer options because that is not fully simplified yet. I can look at what looks most like it, or trying to see, like A definitely is not the correct answer. It's got to be either C, B, C, or D. I'll reduce this one. So what goes into each one of these looks like 6 goes into each one. Divide each by 6, we get 10 plus 2i all over 3. Which again isn't exactly the same as any of those, but it is pretty much the same as D. They just split that into 2 separate fractions, 10 over 3 plus 2i over 3. So same thing. All right, so let's move on to the next problems. Simplify, write your answers in both exponential form and radical form. So first thing we're going to do is just perform the indicated operation. So this is power to a power, which means I need to multiply the exponents. I turn this into 4 over 1. So the base 7 stays the same. So the base stays the same. And then I multiply the exponents. 1 times 4 is 4. Over 6 times 1 is 6, which can reduce to 2/3. So that's my answer in exponential form, but the directions said that I need to write it in exponential and radical form. So to write it in radical form, the big number becomes the radicand, the number on bottom becomes the index, and the power on top becomes the power, which I could rewrite as, my pen would work, sorry. There we go, now it's working. As the cube root of 49, because 7 squared is 49. So that's my answer in radical form. Moving on. The next one, we're now dividing like bases. So the bases are 3, that part stays the same. When I'm dividing like bases, I subtract the exponents. So I'm subtracting 5/8 minus 1/8. 5/8 minus 1/8 is 4/8, which reduces to 1/2. That's my answer in exponential form. I also need to write it in radical form, which is, it's just going to be a square root. The index is going to be 2. The power is going to be 1, but that's not necessary to write. Oops. So that's the other answer. All right, next one. I have 2 options. One option is to distribute the 1/3 into everything, but I would not recommend that at all. I would always reduce what is inside the parentheses first. 27 can't reduce with anything, but the x's can reduce. I'm dividing like bases. One's on top, one's on bottom. That's division. When I divide like bases, I subtract the exponents. Oops. So this 27 is going to stay where it was. This x becomes x to the 6th on top, because 8 minus 2 gives us 6. All right, and then same thing on the next one. The y's, 12 and 9, when I subtract those, I get y to the 3rd on top. What I don't have, I don't have anything left on bottom, so I don't really need to write the fraction anymore. And then my next step is I can either distribute the 1/3 power to everything, or I can rewrite this into radical form. I prefer to rewrite it into radical form. So everything goes under the radical. The index is going to be 3. This power here becomes the index, because what's on bottom becomes the index. The number on top becomes the power, but I don't need a power of 1. That's not necessary to write. And now I just reduce this. The cube root of 27 is 3. And then 3 goes into 6 2 times. That means an even 2 x's get to come out. Then 3 goes into 3 1 time, which means 1 y gets to come out. That isn't necessary that you write the y, but there were none left over, so you don't need to even write the radical anymore, because nothing's going to be left in it. So this is your answer in exponential form. You don't need to write your answer in radical form because the radical fully reduced, so it's not necessary to write. All right, next one, another power to a power. So power to a power, you multiply the tops, multiply the bottoms, leave the base the same. So 6 stays the same. We multiply 2 times 1 is 2, over 2 times 3 is 6. 2 6 reduces to 1/3. That's our answer in exponential form. In radical form, the index is going to be 3. The power is 1, which again isn't necessary to write the power of 1. It is necessary to write the index of 3, because otherwise it would look like a square root if you didn't have the 3 there. This next one, we're just going to start reducing. I'm going to reduce the numbers first, then I'm going to deal with the x's, then the y's, then the z's. So just looking at the numbers first, I try to find two numbers that go into, numbers that go into both 42 and 6. 6 goes into both of them. If you divide 42 by 6, you get 7. And you divide 6 by 6, you get 1, which you don't need to write. Then the next thing is the x's. This is a 4, this is a 6. I'm dividing like bases, so I need to subtract the exponents. So 6 minus 4 is 2. But that one's going to go on the bottom because this one was larger. The x to the 6th was the bigger one, and it was on the bottom. All right. The next thing I notice is I only have y written once, but it's a negative exponent, and that's not allowed. So to get rid of the negative exponent, I flip it to the top. So we have y to the 3rd on the top. And then last, we've got the z's, 7 and 5. 7 minus 5 is 2, so we get z squared on top. And that should be the final answer. Next one, we're multiplying like bases. The like bases are the tens, which means the base stays the same, and we add the exponents. In order to add the exponents, we need common denominators. We can get them both to have a denominator of 14 if we multiply this first one by 2. So 2 times 2 is 4, and 7 times 2 is 14. Add those together, we get 9/14. That's my answer in exponential form. I also should write it in radical form. 10. The index is going to be 14, and the power is going to be 9. I don't expect that you write a 10 out with 9 zeros, but you could if you wanted to. All right, moving on. So something like this is a little weird. We have a square root times a cube root, which we actually can't multiply as it is right now. So what I'm going to do is I'm going to convert this to a different form. Right now, as it is here, this is in radical form. We need to rewrite it in exponential form. So this is going to be 2 to the 1/2 times 2 to the 1/3. Now they're both in the same, now they're both a base of 2. Since we're multiplying like bases, we can add the exponents. We just need to get common denominators. So 2, and I can get a common denominator of 6. So if I multiply this first one by 3, this will be 3/6 times 2 to the, if I multiply this one by 2, this will be 2/6. Add the exponents, we get 5/6. 5/6. That's my answer in exponential form. This is my answer in radical form. 2 to the 5th is 32. This is probably the better way to have it written. So basically, the reason we had to do that was because we can't multiply a square root with a cube root, so we had to convert to a different form. Same kind of idea on this one. We can't do anything in the form that it's in right now. We're going to have to switch things up. The first option is to convert them both to radical form. This is cube root of 2 times cube root of 4. You are allowed to multiply a cube root of 2 times a cube root of 4. You get a cube root of 8. Cube root of 8 is 2. So that's my answer. Or the other option is to change this base. This was a base of 2, 2 to the 1/3. This one was. I also want this to have a base of 2. So 2, 4 is the same as 2 squared. So I just replace the 4. I'll rewrite this a little bit. I replace the 4 with a 2 squared. And then I just multiply 2 times 1/3. So I get 2 to the 1/3 times 2 to the 2/3. And then when you're multiplying like bases, you just add the exponents. So 1/3 plus 2/3 is 3/3, which is just 1, which gives us the same answer. On this one, I think the first method is a lot easier, but those are 2 options for you. This last one, you will have to use changing base. You will have to change the base. This base needs to have a base of 2. So think about 64. 64 is the same as 2 times 2 times 2 times 2. How many times? If you actually multiply it out, 2 times 2 times 2 times 2, 6 times, you get 64. So 2 to the 6th power equals 2 to the 3x minus 3. Now that we have the same base, those bases can cancel out, and we're left with just 6 equals 3x minus 3. Add 3 to both sides, 9 equals 3x. Divide by 3, and x equals 3. And you can plug back in to check your answer if you'd like. 3 times 3 is 9, minus 3 is 6. 2 to the 6th power equals 64. So it works. All right, that's it. Thank you, guys.